Now coming to next important part, continuous wave Doppler. Here you have one piezoelectric crystal which emits the sound, transmits the sound, and the same piezoelectric crystal will receive the sound. Okay, one you send the signal, another one receives the signal, and it undergoes a sequence of 7 steps before getting a Doppler image. Okay, one piezoelectric crystal is there, it will send the sound, at the same time it receives, it undergoes a sequence of 7 steps and you get a spectral image. So continuous wave Doppler gives an assessment of high velocity, that is greater than 1.5 meter per second. The range resolution however is poor and it is site unspecific. You don't know where the maximum velocity is coming from. Now coming to a more complicated Doppler, that is pulse wave Doppler. Here you have two piezoelectric crystal. Okay, one emits a sound and another receives this sound. Okay, one sends it, and once a signal comes back only, then next wave goes in. So lot of complicated terminology like pulse repetitive frequency and those things comes into picture and you get an image. Here it undergoes a series of 14 steps. In continuous it is only 7 steps, but in pulse wave Doppler it is going to be 14 steps until you get the image. So pulse wave is more complex than continuous wave, but it gives a good range resolution and you can find out the site where the maximum velocity comes into picture. The disadvantages, the limitation on maximum velocity is going to be less than 1.5 meter per second. And we are looking at the velocity. There are two types of velocity. One is the laminar, another is the turbulent. Laminar flow is everything, all the blood vessels will be at a uniform speed. Here you can see a uniform speed of blood flow. In turbulent, there is going to be obstruction and the speed here will be different and the speed at the corners will be different. It has different velocity profile. So coming to laminar flow again it can be plug flow or a parabolic flow. What is plug flow is? It is a flat flow with near identical blood flow profile. All the blood vessels will have the same velocity of blood flow and it occurs at initial systole in heart chamber and great arteries. From the LV to the aorta at the initial systole, everything will be at a uniform speed. It is called isovelocity. All the blood cells having the same velocity, and most important thing is it is represented by a narrow Doppler spectrum. And coming to parabolic flow, here there is broad range of velocity. Here you can see the center being high and the side being slightly low. So maximum velocity at the axial center and low velocity adjacent to the vessel wall. It occurs in diastole as the blood moves from the ascending aorta to the descending aorta in the abdominal aorta. To understand laminar flow, it is like a sprint. Initially everything starts at the same velocity, then you can see the axial center gaining more speed and the center part is not at the same speed. Okay, it is axial center maximum and the side being less, but you get a uniform spectral image, that is laminar flow. Now coming to turbulent flow, there is going to be disorganized blood flow due to obstruction and there will be multi-directional current and vortex formation will be there. That is turbulent flow. To understand turbulent flow, it is like a finish of marathon. Everything will have a different speed and some due to obstruction may not reach the required target. Here you get multiple spectral wavelength and images will be multiple. Here there will be uniform in laminar, but it is not uniform in the turbulent flow. So in plug flow you have a narrow Doppler spectrum. In parabolic flow you get slight spectral broadening. Axial center will be maximum and there will be less velocity at this side. And in turbulent you have high velocity marked spectral broadening.